How y'all doing? Dial back here again, and today it's time to leverage the power of the other snack that's famous in Go, which is a package called Cobra. Cobra is very useful for building very pretty good like CLI applications. It allows you to build CLI applications that have multiple levels of commands, and it sort of gives you a lot of things free out of the box, like really nice print messages. You can generate shell completion. It works basically almost right out of the box with another package that is kind of goes hand in hand with this called Viper, which is for configuration. That's what we're going to talk about today. Before we start, one note of housekeeping. If you would look in the description of this video down below, the very first thing should be a link to a Google form. I am now offering one-on-one sessions for mentorship. This could be, whether it's you want to have me help you learn any of the stuff that I've learned how to use, or if you just maybe want to talk about some things relating to maybe your career or just real life stuff. That there you can fill out that form, and I will probably have a small back and forth with you, and then we will try to see if we're going to move forward, and if so, we will schedule the session. So if you're interested in that, should be linked down below. Go ahead and follow that. And with that, let's get started, shall we? So we at the Cobra docs. Look at that. We got Snake, another Snake. Told you, man, you don't step on Snake. So if we go down to just kind of an overview of what it is and the concepts, you'll see Cobra is built on a structure of commands, arguments, and flags. Commands represent actions, args are things, and flags are modifiers for those actions. Saying, good applications will read like sentences. The pattern follow is, app name, verb, noun, adjective, or app name, command, arg, flag. Pretty standard stuff. And some examples of programs that actually use Cobra to build their CLIs. There's the Get CLI program, and then there's also Hugo. And I believe Kubernetes also was built using this too. So let's go over some basic stuff, shall we? Let me go notes. Always need my notes. Okay. So the first thing we're going to do is there's kind of like a recommended file structure for this, but for the purpose of this, we're not really gonna mess with that. But we will go over that sort of when we talk about the generator that you can install with Cobra. So I've already initialized the Go module in this directory, and I've already downloaded and installed the Cobra package. So let us create our first command, shall we? Okay. So the way you create a command is, I'm going to start by declaring a bunch of vars up here, and we're going to do root cmd equals a pointer to cobra.command. Now, commands have a lot of properties that you can set, but realistically, for most of the examples I've seen, you tend to only really use maybe 3 to 5, maybe 6 of them. A lot of them are also used for like more edge cases, but we'll get to that as we get to it. So the 3 or 4 that I see used like all the time, so there's use, which is basically like the name of the command itself that you'll see in like the print usage and stuff. So we're just gonna call this example. This is our example program. And then we're gonna have another property here called short. This is like a very short description of this command. And I'm just gonna say can't spell today, an example Cobra program. Then there's a long one, which, as you might guess, is basically just a further like elaboration of what the short summary is saying. So I'm going to do like a string literally here. I'm going to say this is a simple example of a Cobra program. It will have several subcommands and flags. It's like that. And that's all it's going to have initially. But we're going to add some more stuff to it here soon. So let me get ready to get rid of this. Okay. So we've created our command. Now how do we actually use it? I'm going to do if error equals root command dot execute error equals nil, does not equal nil, log dot fatal the error. So the commands have an execute thing, or specifically the you tend to just execute the root command. I think maybe you can explicitly execute the other ones, but all the examples I've seen, they're just kind of done by calling the right chain of commands, if that makes any sense. So if we run this right now, I think it probably won't do much. Like it'll just, yeah, see, it just prints this information because we don't really have anything here. But I believe also by default we should have, yeah, okay, it was printing the help message, but we don't have anything. We don't have any flags. We don't have any subcommands, so it's not really doing a lot here. So let's make this root command do something, and you do that with the run property. The run property wants a function that takes in an argument of a pointer to a Cobra command, which is typically which I usually is the command itself, and then a args, which is in a slice of strings, and then we're just going to fmt print line hello from the root command. And yeah, it's complaining because I don't have that trailing comma. And we'll run this, and you'll see now, because we have this actually doing something, you'll see it prints out a little bit of some usage information. It's sort of similar to what you see from the usage function on the standard flag package, but it's got a little more info here. So it just has an example of how to use it, and the flags that are here by default, it automatically gives us a help flag. So if we want to actually do this, we're going to get rid of the help, and we're just going to run it, and you're just going to see hello from the root command. So there's no subcommands yet, so all I did was basically call the function in this command's run property. So let's add some more logic here, shall we? Let's give this root command some flags. So in the init function, so Cobra has the concept of two different types of flags, basically. There are persistent flags and just flags, also called, I think, local flags. So the difference between a persistent flag and a local flag is a local flag is only available and only relevant within the context of the command it's defined on. Meaning, if on this root command I define a local flag, and maybe I'll whatever I call it, it will only be available when the root command is the root command being processed. If it's being say tossed down to a subcommand of the root command, that flag will no longer be relevant anymore. However, if it's a persistent flag, persistent flags stay available and relevant starting at the command they're defined on and any other command that's a subcommand of that command. That's probably a little confusing, but I'll demonstrate. So we're going to define two flags on this command. We're going to do root command dot persistent flags, which will give us our, oops, I always keep putting dots here, stop it. That will give us our flags that we can modify. And I'm just going to put a Boolean flag on here. I'm just going to put a bunch of Boolean flags, basically. So bool var p. You'll probably recognize the bool var syntax from the standard flag package. The p is Cobra supports this fork of the flag package called p flags, which are kind of more like POSIX compliant flag format package. And I tend to use those a lot when I'm using with these because, yeah, as someone who's using Linux a lot, I tend to like that format a lot better. So I need to actually declare this variable that I'm dumping this into. I'm just going to call it what's called a root, local root flag, and it's a Boolean. And we go back over, I'm at right here. I'm at bool var p. Okay, I gotta pass in a pointer to my local wait, this is not local, this is persistent. I'm getting ahead of myself. Persist root flag up there. I was getting ahead of myself. So persist root flag. And we have a couple arguments we gotta pass in here. One is the long name of this flag. So I'm just gonna call it persist flag. And then for the single character shorthand, I'll just call it P. Yeah, we'll call it P. And by default, it's false. And a persistent root flag. So now, if I weird that did it automatically format like that? I've never seen it format like that before. Interesting. Okay, so if we run help now, you will see that we have our new flag here, right? And this is persistent. So if I go to demonstrate that it'll actually still be there, we need another command. So it's not very often that the root command actually has a run property on it. Typically, it's just kind of like the entry point, and all of your subcommands are the things that actually have, I guess, behavior attached to them. So let's create another command now, shall we? I'm just going to call it an echo command, and you define it the same way as before. Cobra.command. Use. I'm just going to call it echo. Say echo, and then strings to echo, because we're basically just echoing out strings back to standard out. The short description is prints given strings to standard out. Okay. I'm not even going to bother with a long definition. And now we're going to also make use of another property you can set here called args. And args, you can set some filters here that Cobra will use to enforce that the person is using your program the right way. And I'm going to make use of one called minimum in args. So cobra.minimum, I can't spell minimum in args. And what this basically says is whatever integer I pass here, whenever you run this command, it has to have at least that number of args or it will throw an error. So I'm going to say, well, this has to have at least one argument. So if I were to say, if I would call my program and then call echo and then not give it any arguments, it would throw an error. And so now we're going to have our run function that looks similar to the one up above. Cobra command, Cobra commander. That's probably what that reference is if I had to guess. And we're just going to do the same thing up here. Say echo. I'm going to do strings.join on the args. And then just put spaces between them like this. With the trailing commas. And I'm going to get rid of this now because we don't need it. So now, we also get some other interesting information now. If I run help, whoops, what did I forget? Oh, wait. Yeah, well, actually, so let's do, if you give this like a flag that you don't have set, it'll just print out the usage information like this, because it'll say, oh, that's what I forgot to do. So, whoopsie daisy. So after you've created your command, you need to actually add it to the root command to have it hook everything up. And to do that is straightforward. You just do root command dot add command echo command. So now the echo command is now part of our command tree. And if I run this again, now you will see there's something extra here. It says available commands, echo and help. And you will see that the info here is that shorthand message we had here. And now there's a help command, which will basically give you this information about this specific command. And you'll see we still have these two flags here like this. So now if I run this, but I do help on echo, it's just going to print out small information about that echo command. Notice now here there's a flags, which is local specific to echo. And there's one where it says global flags. these are the persistent flags that were defined in a upper level command. So if let's go back to the root command. If I define another flag on my root command, but instead of persistent flags, I just do flags. These are local flags. This will only be available to the root command. So I'm just gonna call it boolvar p, and I'm gonna have another variable here, and I'm gonna call it local root flag, local flag, L false, a local root flag, like that. Yeah, I need to actually create that. Local root flag, bool. So you will see if I run this again, we don't see that local flag there. That's because it's only available to the root command. But if I just run help, you will see now that it is here because when you call help without pointing at an actual command, it basically just prints out the help info for the root command. And you'll see that now we have all of the top level flags here present and ready to use. So now let's actually use our echo command. So we're going to do echo, and we specified that we could just pass in, basically a bunch of strings. So I'm going to say hello world from Donald, and you'll see that it ran the function attached on the run property on our echo command, and it did exactly that. It took all the args, which was this big bunch of strings right here, and just joined them with spaces. So, and we got boom, hello world from Donald. What else we got here? So my brain is not working today. Okay, so we specified that there had to be there's a requirement here, right? So if I get rid of all these arguments and I just run like this, we see we get an error, and it's coming back through any errors that are returned from these functions. They just get basically propagated back up to the root command, as far as I know. And basically what happened was we got our error returned here, and I just logged it and was log.fatal. And you will see it says requires at least one arg or args, only received 0. That's basically telling us you didn't pass in enough arguments that we said you had to pass in. So we have a root command and we have a subcommand. Well, we can go as many levels deep of this as you want. We can have a subcommand under another subcommand. So let's do that. Let's give the echo command some extra special functionality, and we'll call it times command. Cobra.command. Use is times strings to echo. So it's still kind of building off the previous command's usage. Short. Print given strings to standard out multiple times. See, it's the same functionality, but it's modified. And it's going to have the same criteria: minimum in args 1, and run. This one's going to be very similar to the last one, but we're going to change one little thing. So let me go up here, and I'm going to define another flag here called, I'm just going to call it times int. And we're going to give this times command a local flag. So times cmd.flags.int var p times, and call times, and the shorthand is t. The default is 1. Actually, let's make it 2. No, it's 1. And it's the number of times to echo to standard out. Like that. And also, we have to remember that before we go up here, we need to add that command. So, but we're not going to add it to the root command. We're going to add to the echo command. So echo cmd add command. Oops, I didn't capitalize that command times cmd, like that. Now let's actually do our function here. Func command pointer command cobra dot command args string, and it's basically the same thing as this, but we're just going to loop over it. So we're just going to do for I is equal to 0, standard for loop, I is less than times I plus plus plus. I'm just going to do fmt dot, actually I can just grab this instead of typing the whole thing back up. Fix that up, put that there. Purdy, okay. So we should have a bunch of new stuff in our help information too. So let me just run help. And we do. We have, well, you won't see anything about this. Yeah. We have to do help echo. Now, if we run help echo, now you'll see we have a couple of, we have another additional commands thing is still here. And we have our times command is now embedded in this. And we can go this further. We can say help echo times. And this will give us the help information for that echo times command. And you'll see our times flag is here. Number of times to echo to default, or to standard out, default is 1, because this is all the information that we set on the flag. And it has the same rules as before. It has to be at least 1 arg. So let's actually run that and try it. So echo times. And let's see, we're gonna do hello world, and let's not actually pass in a flag. So this should only do it once, right? Okay, did it once. And but let's say that we say times t is 5. Do this boop, and it printed out 5 times. So we have successfully had a multi-level command. Each one has their own flags and has like their own help information. And we can interact all of them in a way not dissimilar from how you would use something like Hugo or Kubernetes. Let's look over at the documentation or the README to see if there's anything else here of interest that I might want to go over. Let's see. This is just kind of going over a lot of the stuff. Yeah, there's I guess this is probably worth doing actually. So there's a variant of this run property called run e, and the only difference is that run e can return an error. You can explicitly return an error, and if you do, it'll just get propagated back up to the top, like how if you didn't pass in enough arguments, that just implicitly returns an error. So like let's do that for example. Let's do instead of this being this, we'll do e. And then this has to specify that it returns an error, like that. And I'm just gonna do, oops, return, where is my cursor? Thank you, return nil. So let me do, let's have this like really weird edge case where if I have said for some reason that time is 0, that it'll error, okay? So let's do if, where am I at? If times equals 0, return errors.new times cannot be 0, like that. So now if we run this, so where was this? So if I said this was 0, you see it did actually error out, and when it errors out, it just prints the help info by default, and you will see the error was error times cannot be 0. That was our error we explicitly returned. What else here? This is all stuff about flags, persistent flags, local flags. Oh yeah, so it says by default, Cobra only parses local flags on the target command. Any local flags on parent commands are ignored. By enabling command.traverse children, Cobra will parse the local flags on each command before executing the target command. So what that means is, if I go up here, remember how we had defined up at the top a local root flag? So if the root command isn't our target, this basically just gets ignored. It doesn't even bother with it. But in our top root, like our root command, if we had specified this this property right here, it would actually process each local flag as it goes down through the command hierarchy. I don't particularly find this super useful, but I'm sure there's use cases where it's helpful. This talks about how to use it in conjunction with Viper. This is kind of outside the scope of this video. But you get a good example of this whenever we talk about the generator here in a minute. Oh yes, this is flags are optional by default. If instead you wish your command to report an error when a flag has not been set, mark it as required. So you'll see here, it gives an example where it has a flag called region, and you can say, well, this is required. So we could use this on our times function, our times command. So let's say that I do times command dot, what was that? It was mark flag required, yeah. And it's times like that. So if our target command is the times command, it's going to error if we don't give it this flag. So if I don't do this now, it's going to say required flags time not set. Yep. What else was there? Positional and custom arguments. So this is the validator that I was talking about. See, we already made use of this one. Command report an error if there are not at least n positional arguments. But there's a couple others. There's max arguments. There's exact number of arguments. You can make it throw an error if there are any non-valid arguments passed in. This means it'll take anything. No args, meaning like if you pass in any args, it'll be like, hey, you're passing in args when you shouldn't pass in args. This will throw an error if there isn't exactly the exact number of arguments you specify. This is both basically exact args and valid args. Yeah. And there's also an example of how to do like your own custom validator, where instead of using something like this, you define your own function that has a similar structure to the run e function. And then there's a lot, if length is less than 1, return this error, return this error. Yeah, it's just showing how to make your own like argument validator on a command. And there's just an example, and it's talking about the help command that gets generated. I've already shown you that. Shows you the usage information. I've already talked about this. You can define your own help and use information with a couple of different helpers. You can set your own help command. You can pass in a function pointer to do that. You can pass in a template to parse. Same thing with usage. There's these hooks you can run. These seem useful if your command maybe has to do something like ensure that it has like a database connection or something. Because and it demonstrates here that there's like the order it runs. So there's 5 hooks. There's persistent pre-run, run, post-run, and persistent post-run. It does specify that if a subcommand is going to be ran, whatever the top level command was, if it has a persistent pre-run, it will be executed before the subcommand runs, but it will not. But nothing else here will be ran. There's also automatic suggestions, which is pretty interesting. Did I do that? I don't think I actually did that. Let me let's actually try that. So this should already be right out of the box. Instead of time, instead of times, what if I typo and put time? Oh wait, yeah, that's still technically a valid thing, isn't it? So maybe instead of put echo, I put ek. Yeah, see, unknown command ek, for example. Did you mean echo? So it already has some auto suggestion built into it. It says it does it using what's called the Levenstein, I think that's how you pronounce it. Basically what Levenstein is, if I remember correctly when I had to use this once, is the Levenstein distance is if you compare two strings, the Levenstein distance is the minimum number of individual changes you have to make to each character in one string to make it equal the second string. So in the case of my ek versus echo example, the Levenstein distance is 1. Because the only thing we have to do to change it to make it the same is add an O to the end of the ek string. If I did something like EC, you see it still autocorrects. Now if I put E, I think it won't do it. I did still do it. Okay. But in the case of this, the Levenstein distance is like 3, I think. 1, 2, 3, yeah. What else? You can generate documentation. You can generate shell completion. You can read about that on your own. Last thing I wanted to go over, which is useful, is it has its own generator, which is super, super nifty. You can initialize your own app, and you can use it to add commands. So let's actually look at that real quick, shall we? I'm going to actually completely close out of this and see. I'm gonna close out of this because we're just gonna use this top screen. I'm gonna go up to my top level projects thing, and I already have this installed, and I'm gonna init. I'm gonna call the package. It doesn't really matter what I call it. GitLab.com /DAC 425 / Cobra gen example. And I'm going to put it in a directory called Cobra gen example. Boom, it says your application is ready at this path. So let's go into Cobra gen example. Let's actually see what it actually made us. So there's a license file, and there's a command directory and a main.go. Let's look in the main.go. You'll see that this is following the standard format that it recommends in the README documentation. Is that your main essentially just becomes you import the command package in your own project, and you just call execute, and then everything else happens within the command directory. So let's go see what that is, shall we? Let's look in command. Made us a root. Let's look at the root. So it already has a couple things set up for us. It already has a Cobra command set up for us, a root one. It also has a config file defined. And it's just, here's an example of a lot of the stuff I talked about: the use name, the short description, long description, the run property for it to actually do something. Here is the execute command that has basically what I had in the main function in my example. And init is where it often recommends you do a lot of the setup. And you'll see there's also a function here called onInitialize, which is like when the root, when Cobra is first started on this root command, it'll do this function, which is this init config function is down below. It's basically using Viper to read in a config file to have all your information ready, all your configuration information ready. And here's an example of your global persistent flags, your local flags. And then here's an example of it interacting with Viper, where it's using Viper to set the config path, the name, read in environment variables, and then read everything in. That's I think this exact same thing is actually on the README, but it's just a very quick way of getting stuff up and running. And it even has a if you want to add additional commands. So it's like it says, if you wanted to add a serve command or a config command, we can do that. We can go, if I go back up here, I can do Cobra add, and I do config. Config created. If I go down the command, now there's a config one, and it's just kind of like a very simpler boilerplate. It actually already adds it to the root command. I believe if you declare this in like a nested command, so like let's go back up. If I do Cobra add config init like this, and we go look at cmd. Cd. Oh, I can't type cmd. Oh wait, is it in the config? Maybe it is. Oh, okay, I'm not real sure where that went. The example did not lie to me. Oh, right. I made a whoops. You have to, if you want this to be parented under another command, you have to pass in this -p flag to set the parents. Yeah, right. So I'd want to go back up and do the whole Cobra thing again. But I'd want to do, what was it, inet p config cmd, like that. Okay, yeah. So now we should have, yeah, there we go. So now we have our inet command, and you will see that it's being added to the config command and not the root command like the other one was. Yep, so there we go. That should be a very, very general overview of Cobra, how to build commands, how to add sign flags to commands, how to add subcommands to commands, and etc., and also a brief example, a lot of the really nice stuff you just get out of the box when you use Cobra. That's all I got for you today. If you liked the video, be sure to share it. If you're new to the channel, be sure to subscribe to know when I put more tutorials up. And with that, y'all come on back now, and I'll see you next time.